We're back for part 2 of the observation on Mercury. You should, at the end of part 1, we had Mercury was magnified, so we had a chance to sort of get up close to it. The first step in part 2 is to zoom back out, and the way that you do that is you use this icon here. That will give you your standard field of view. And so if we just click on that, we'll go back to our standard field of view. If you hit your space bar, you'll get there a lot quicker. Okay, so here's Mercury, and I have enabled the boundaries of the constellations. You can do that by going up here to View, scroll down to Constellation, and click on Boundaries, and then the boundaries will show up. I'm not sure what's happening here. Oh, I see what's happening. Let me go ahead and cancel that out. All right. The next step is don't send. The next step is to enable the program to show you the Mercury's orbit. So you right-click on Mercury, and then you look for orbit, and you select orbit. Now, Mac users are going to have to use the method that they tell you to use in the beginning of the book, or the beginning of the workbook. Yeah, there's an introduction that you can download, and it tells you gives you an introduction how to use the program. So we can see now Mercury's orbit, and if we disable the horizon, we can do that. And then if we turn off sun daylight, we see that. Now, I have previously set the sun so that we don't get the halo effects. If we show you halo effects, it would look something like this on your screen. But I like to disable that when we're working here, because it makes it a little easier. So here's the sun right there. There's Mercury, and you can see that it's going in a it's orbiting the sun. Now you can also see that it's from this view anyway, it looks like it's at its apihedron. The instructions tell you to center on Mercury, and then to put it at 1 day and let it run. Then later on they tell you, but it works best if you center on the sun. So I'm going to go ahead and center on the sun. We're going to select, we're going to center, we're going to select the sun, and we're going to center on that. Here's Mercury right here. And going to change the time to 1 day per click, and then I'm going to start the simulation, and we can watch as Mercury orbits the sun, and as it does so, you can see that it orbits the sun. Now there are two maximum positions that, and I'm going to go back to now, and then back to sunset. There are 2 points when viewing Mercury from the Earth. There are 2 positions where Mercury is separated from the sun its maximum amount. One is when Mercury is to the east of the sun, which makes it a evening star, and that's the way it is right now. It turns out that February Mercury is an evening star. I'm going to enable the horizon, and this is it's at sunset, and I'll even show you here if we move it forward towards daylight. Well, if we do, it's going to set before it. You won't be able to see it, so I'm going to move it back. The sun is set, and but it's still not dark yet. It's dusk. And but the important point here is that there are 2 points of greatest elongation. Greatest elongation means that Mercury is furthest away from the sun in the sky. At the point where Mercury is furthest away from the sun in the sky as we view it, that's called greatest elongation. And there's two types of greatest elongation. One is when Mercury rises after the sun and then therefore sets after the sun. And that's where we are now in February of 2013. And at that point, in order to measure this greatest elongation, what you do is you go ahead and select from the control panel the angular separation tool. You put it here on the orbit, and then you draw it down into where the sun is, and then you can read it. It's basically 18 degrees. And you can read that angular separation there. It's in red, 18 degrees. Now the other point occurs, and let's get rid of the horizon and the sunlight. The other point of greatest elongation occurs over here when Mercury is to the west of the sun. And so at that time it will be a morning star. Right now Mercury is an evening star, and when it moves over here to be west of the sun in its orbit, then it will be a morning star. So all we have to do is advance it. We'll go ahead and advance it to the point in time when let's select Mercury so it's showing. In a point in time when it's furthest away from the sun, and if we go to sunrise and put in our horizon and even put in some daylight, and then give it a few hours more, we'll add a few more hours here just to see. Okay, so there you go. Maybe hours was too much. We'll back it up some. Put the sun below the horizon. Okay, so now here we are. We're at sunrise, and March 29th, 2013. And at this point, we can see that Mercury is right here, and the sun is somewhere down here. We're going to go ahead and select it so that we have a good place to measure from. Okay, at this point, Mercury is at its greatest elongation for when Mercury is a morning star. And basically, at that point, Mercury is furthest separated from the sun, and we measure the angular separation by going from here from the sun to where Mercury is, which is basically right out here, and you get a pretty good you get an angle of 27 degrees 42 minutes. So that's how you calculate your angular separation for the two. It's called the greatest elongation. Now, if we come back here to now and hit sunset, we can see that actually Mercury is just a little bit beyond its greatest elongation, or it hasn't quite got to that very end point there. In the info guide, I believe it tells us, oh, we are focused on the sun, so we'll have to go back to select Mercury for our information. And I believe in position in space, position in the sky, you have elongation here. Right now its elongation, its distance from the sun is 18.0 degrees. So there are two ways to do it. You can actually measure it, or you can use the information guide and it will tell you. Now the point of greatest elongation occurs right there at the end, and I believe that occurred a few days ago. So I am going to back it up. And so there it is. It's somewhere right in there a couple of days ago. All right. And the greatest the elongation here was 18.1 degrees east. Now you can measure that. Again, we have to see the sun, so we'll turn off the horizon. And we can measure it from here to the sun. And you can see it's basically 18 degrees, 5 minutes, 32 seconds, or rounded off 18.1 degrees. And that's where it is now. And that also happens to be, well, that is the greatest elongation. Right now, if we go to now and then go to sunset, we can see that we're not exactly at greatest elongation. We're somewhere less than that. And again, you measure it by using the angular separation tool. I roll my cursor over the point I want to measure from. I right click, and then I draw it to the point I want to measure to. And here we have 18 degrees 3 minutes. Okay, now the next step in the process is to take a look at this from a three-dimensional view where we see all of the planets, including the Earth. You go to Favorites, you scroll down to Solar System, then you scroll to Inner Planets, then you go to the Inner Solar System and you click that. Now this thing is running, so it defaults to someplace in 2007. So we want to click Now, and that will tell you where the planets are right now. Okay, turn it off. That tells you where the planets are right now. Take a look that at the point of greatest elongation, when Mercury is an evening star, if you take a look here, notice that the Sun and Mercury and Earth form a right angle. Okay, they form a right angle there. And so as seen from Earth, Mercury is furthest away from the sun in the sky, because it's in a point in its orbit where from our position it is at a right angle from the sun. Now the other point of greatest elongation is when Mercury is down here, over here. Now there were two other conditions. One was called inferior conjunction, and we did this in part 1. Inferior conjunction is when Mercury is directly between the Earth and the Sun. And superior conjunction is when the Sun is between the Earth and Mercury. Okay, what else do we need to know? You need to know what the dates are of greatest elongation, and if you take the absolute greatest elongation, then that's going to occur when Mercury is a morning star, and you can take whatever value you get for that. So that's part 2. A lot of people have trouble with part 2, so should be more clear now.